Morning, everyone. So some of you may have already seen this lesson in class, but we're going to be talking about solving trig equations. And might be a little bit muffled as well because I've got my mask on as I'm at school. So just want to kind of make you aware of that. So taking a look at our first two problems, there's, we can solve both of these equations, but they might look a little bit different from kind of what we've seen in the past, but in both cases we can use our unit circle. So in the situation on the left, if I cover up that equals x, it almost becomes a little bit easier, and you just see sine of pi over 4. And essentially that is, hey, take a look at your unit circle. We know that the sine is the y-coordinate. So at pi over 4, I can say that x equals square root of 2 divided by 2. Okay? On the right-hand side, notice that our variable is actually within the sine function, and we know the value on the right-hand side is 1. So this is a little bit different. This is more what angle leads to sine of x having a y-coordinate of 1. So before, you would look around the unit circle for the angle and then go out and find the coordinate. And now we're kind of doing the opposite. We're going out and looking for the coordinate and then coming back in and finding the angle. And what we might notice is that we can kind of get multiple solutions to this. So one thing's kind of important is the first angle that I come to here that has a y-coordinate of 1 is pi over 2 or 90 degrees. Some other solutions to this second equation here is going to be every 2 pi after that. So, if I have 90 degrees and then I add 360 to it, that is also going to be the same solution to sine of x equals 1. So here, if I have x equals pi over 2, if I add 2 pi to that, I'll end up with another solution. So 2 pi is really like 4 pi over 2, right? I need to have common denominators. So another solution here is 5 pi over 2. And I can keep adding instances of that if I wanted. Sometimes when we state the answer to above, we'll say something like pi over 2 plus k times 2 pi. And that kind of takes care of all of the multiple rotations that we could have here. So k could be 5, and that would mean, well, if I went forward 5 exact rotations, then I would have a solution as well. When I get to involving these or mixing these with other equations, I really don't stem too far from that kind of basic understanding of I'm looking at the unit circle for an angle and then or for a coordinate and then trying to work backwards from there. So one adjustment I know I need to make is to make that a 2, just to kind of make that much more convenient for us. But if I'm looking at some of these problems and trying to solve them, I want to isolate my cosine of x first and or combine my cosine x's. So here I'm going to take away a cosine x from both sides. So on this side I just have square root of 3. On this side I have negative 2 cosine x. Going to divide by negative 2. So now I have negative root 3 over 2 equals cosine of x. This would mean that I'm going to be looking on my unit circle for an x coordinate that's negative root 3 over 2. So that should be this angle and this angle. Okay, so I'm looking for what are those on the unit circle, and that should be 5 pi over 6. And I'm going to write kind of my answer like this, and 7 pi over 6. Okay, so this answer notation is called set notation, and I'm just listing out my values. An important kind of part about the directions here is we're only listing the ones that fall in between 0 and 2 pi. So we're not going to take into consideration any of those that exist like every 2 pi after that. So I don't need that extra plus k times 2 pi situation. So if we're moving on to the next one, again, I'm trying to isolate theta, so I'm going to try to get sine squared theta by itself first. So if I draw my little magic line here, I'm going to add 3 to both sides. So I end up with this. Okay, I'm just going to kind of keep tackling this as best I can. I end up here. So I'm just going to write that as 3/4. This is a little piece of notation that we need to recognize. So if I read that left-hand side, as it's read, it says sine squared theta. And what that means, so sine squared theta is the same thing as sine of theta squared. We don't write, generally you will not see this, okay? And that's because if I was reading that to somebody, I would say the sine of theta squared. And you don't know if sine is being squared or if theta is being squared. So if I need to square a trig function, I do it in between the angle and the 3-letter representation of that trig function. So I do it in between as opposed to at the end. And that's so that we could read it to one another and we don't have to say the sine of theta squared. Okay? So you won't see this unless somebody really wants to do theta squared. So that's just kind of important to know. It does mean that down here, in order to get to closer to sine of theta, that I need to do this. So if I square root that side on the left, I can actually square root top and bottom separately. And this is going to give me the square root of 3/2, which, if I go to my unit circle, I'm looking for now a y-coordinate. That's square root 3/2. So I know that that is these angles. So that is going to look like pi over 3, and then I believe 2 pi over 3 as being my answers. Okay? Tangent of theta, this one is going to be a little bit tricky because it requires, obviously tangent is opposite over adjacent or adjacent over opposite. So I'll get all the way down to, being pretty close to it, and then I'll probably leave some work for you to figure it out. But let's take away tan theta from both sides. Once I do this, I end up with 6 tan theta. So now I'm here, I'm going to divide by 2 on both sides. Divide by 3 on both sides, so I have tangent of theta equals root 3/3. And what I can say about this and what we'll kind of check in on is this is either going to be some multiple of 30 or 60. And what I would do is take the tangent of pi over 6, take the tangent of pi over 3, and figure out which one gives you that square root 3/3. One of them gives you just square root 3, but just for kind of time's sake here, I might not do it. And I know it's not a multiple of the 45s because those end up being 1 or -1. And I know it's not 0, 90, 180, or 270 because those end up either being 0 or infinity. So that just kind of saves me some time. So in the rest of these situations, we're essentially trying to isolate the trig function, get it by itself, and then using the unit circle in reverse to determine the angle. That is, actually I'll do one more, which I think is kind of unique here. Which is maybe this last one. So I'll do this last one as kind of an additional learning opportunity here. So add 1, 2 times the sine of 2 theta equals 1. I'm going to divide by 2 on both sides. So now I get this. I need to undo my sign right now, so I'm looking for where is my y-coordinate going to be a half. So that's looking like these angles. So that would be, and what we end up getting here is that 2 theta could equal pi over 6, or 2 theta could equal 5 pi over 6. So I actually end up with, notice, 2 different equations, because when I undo this sign on both sides, I'm still left with 2 theta. I'm not actually at my final angle. But to finish solving these, I'm just going to divide by 2 on both sides. So this would imply that theta is actually pi over 12. and this would imply that theta is 5 pi over 12 as my two different solutions. So that'll also kind of help you with some of these lasting problems. Your goal is to complete these problems to the best of your abilities. This last one ends up being a little bit tricky, but that's totally fine. That's kind of part of the game, and see what you can come up with. Thanks.